Good morning. Today we are going to work with conic sections, and we are going to be working with parabolas. A parabola we have covered on chapter 4 as part of the quadratic equations, but today we are going to cover parabolas in the context of a conic section. If we have a cone and we slice it, that will form a parabola. On the parabola has the following components. It has a vertex. It also has a focus. And we also have the directrix. So we have three components. We have the vertex, the focus, the directrix. We are not going to deal so much with the line of symmetry. We covered the line of symmetry on quadratic equations back on chapter 4. And the parabola has the property that any point on that parabola is equidistant from the point called the focus and the directrix. Basically, if you go from any point on the directrix, you go towards the parabola in a 90-degree angle and back to the focus, those two segments will be the same. If we start from any point on the directrix, up to the parabola and back to the focus, those two segments will be always the same. So if you start from here, anywhere on the parabola, it can even be from here, you can go up to the parabola and over to the focus. Those two segments will be congruent, will measure the same distance. Now, let's go and look at the equations of a parabola. If you guys notice, we have two equations, and if you don't have the graphs, you can go and come to the classroom and I can go and give you both graphs. If not, you can just go ahead and graph them or just make a sketch. If you guys notice, they both only the x or the y will be squared. If the x squared is facing up or down, just like the ones we covered on chapter 4 for quadratic equations. If the 4p is positive, it's facing up. If the 4p is negative, it's facing down. If we have the y squared first, it's going to be facing left or right. If the 4p is positive, it will be facing to the right. If the 4p is negative, it will be facing to the left. And one of the ways that I memorize which way is it facing, I actually extend this to say, okay, if it's 4py, that means that's facing the y. And then on the other side has to be x squared. If it's 4px, I know that's facing the x-axis. So it's facing the x-axis. If it's positive, facing the right. It's negative, facing the left. We also have the vertex, very similar to what we covered on ellipses and hyperbolas. The vertex is h and k. And because of the formula is negative h, that means that h will be the opposite when you plug it back in, or when you get the value of h. And same thing for the k, because the formula says negative k, so this will be the opposite. Now, P is the distance from the vertex to the focus. So P will tell us how far the focus is away from the vertex. So let's go through example number 1. The first thing that I want you guys to find out is if the parabola is facing up, down, left, or right. And the way I memorize this is I look at the negative 8x. So which one is it facing? Up, down, right, or left. So I look at the negative 8x. The negative 8 on the x, this is your x-axis, so the negative 8 on the x is here. So your parabola will be facing to the left. Let's look at example number 2. Negative 3y. So that means your parabola is facing Correct. It's facing the negative 3 on the y. So it's facing on the y. It's facing down on the negative 3. So this one will be facing down. Let's go to the back side. On the back side, example number 3. Notice that the vertex, we do have a vertex which is 1 and negative 2. But I just look to be able to determine which way is it facing 12y. So it's facing the y, the 12 on the y-axis. So it's positive y, so it's facing up. If that was a negative 12y, then it will be facing the negative 12 on the y. It will be facing down. You can find any other way to memorize it, but I just find this much easier. So let's go through the process of graphing. We have example number 1. Draw out a given parabola. First, I need to be able to find my vertex. My vertex is h and k, because notice there's no h and k. On example number 3, we do have an h and a k, but on this one, we don't have an h or k. So your vertex, and I'm going to write it down on the left-hand side. My vertex will be 0, 0. So it's located here. Now, I need to be able to find my focus. I know that P is the distance from the vertex of the focus. P will tell me how far the focus is away from the vertex. So I need to find the value of P. So let's go and find P. Because of the formula, because the formulas have 4P, we know that negative 8 has to be the value of 4P. So you always going to set up 4P is equal to this number. 4P is equal to negative 8. It's 4P is always to this number. So in this case, on problem number 2, that'll be 4P is equal to negative 3. So to find the value of P, you let 4P is equal to that number, whatever is there. In this case, it's negative 8. I'm going to divide by 4. Divide by 4. That cancels, so P is equal to negative 2. Remember, your focus has to be inside the parabola. And I'm going to make a quick sketch. So it's facing the left. And P is negative 2. So I'm going to go to the left 2 for my vertex. 1, 2. And that'll be my focus. This is my vertex. Now we also have something called the directrix. The directrix will be on the opposite side, the same distance. So we went to the left 2, so I'll go to the right 1, 2, and I'll make a dashed line, and that'll be my directrix. I need to find the equation for that line. It's crossing the x-axis, so it's going to be x is equal to, where is it crossing the x-axis? At 1, 2. So x is equal to 2. That'll be the equation. Now I need to be able to find additional points on the parabola. So I need to be able to plug in different values for x. So let's go and plug in let x is equal to, you always want to go inside the parabola. So I'm going to let x equal to negative 1, because that will give you 2 points, and you guys will see why. So you always want to go inside the parabola. So this is your vertex, you go towards your focus, you go negative 1. So x is equal to negative 1. So instead of the x, I'm going to replace it with a negative 1. We have y squared is equal to negative 8, but instead of the x will be negative 1. That'll be y squared is equal to negative and negative is a positive. I'm going to take the square root on both sides. The square root and the square cancel, so y is equal to the square of 8. I'm going to write down on the left hand side the perfect squares. We have, I know that the square of 1 is equal to 1. The square of 2 times 2 is 4. The square of 4 is 2. The square of 9 is 3. The square of 16 is 4. So the square of 8 is between 4 and 9. So it's a little closer to 9. So it'll be about 2.8, 2.9. It'll be 2.8. And every time that we take the square root on both sides, we have to make sure we have a plus or minus. So remember, if we take the square root on both sides, we have a positive and a negative. That will give us 2 points. So for both points, the x value is -1. So I'll be -1 for the x value. The corresponding y value, one of them will be with positive 2.8. The other one will be with a negative 2.8. And I'm going to go and plot both points. So it'll be -1 and 1, 2.8, and -1 and 1, 2.8. I'm going to need another set of points. So now I'm going to let x is equal to, I'm going to go once again, -2, because that will give me those 2 points. And I'm going to plug in y squared is equal to -8, but instead of that, x will be -2. That'll give me y squared is equal to negative is a positive 16. Now, if by any chance you get a negative number here, you know that you actually plugged in the incorrect number. So just be careful, because you will not be able to take the square root of a negative number. The square and the square root cancels, so I have y is equal to 4, and let's not forget our plus or minus. So that'll give me 2 points. The x value for both of them is -2. The corresponding y value, one of them is a 4, the other one is a -4. And I'm going to go and plot both points. So for my origin, I'm going to go 1, 2, and 1, 2, 3, 4. And for my origin, I'm going to go -2, and 1, 2, 3, 4. And that will shape my graph. So my parabola will be, actually I was not too far away, will be right here.